A large portion of the population is at the mercy of a rising technology, yet few actually understand what it is. Artificial intelligence. You know, HAL 9000 and Marvin the Paranoid Android. Thanks to books and movies, each generation has formed its own fantasy of a world ruled, or at least served, by robots. We've been conditioned to expect flying cars that steer clear of traffic and robotic maids whipping up our weekday dinner. But if the age of AI is here, why don't our lives look more like the Jetsons? Well, for starters, that's a cartoon. And really, if you've ever browsed Netflix movie suggestions or told Alexa to order a pizza, you're probably interacting with artificial intelligence more than you realize. And that's kind of the point. AI is designed so you don't realize there's a computer calling the shots. But that also makes understanding what AI is and what it's not a little complicated. In basic terms, AI is a broad area of computer science that makes machines seem like they have human intelligence. So it's not only programming a computer to drive a car by obeying traffic signals, but it's when that program also learns to exhibit signs of human-like road rage. As intimidating as it may seem, this technology isn't new. Actually, for the past half a century, it's been an idea ahead of its time. The term artificial intelligence was first coined back in 1956 by Dartmouth professor John McCarthy. He called together a group of computer scientists and mathematicians to see if machines could learn like a young child does, using trial and error to develop formal reasoning. The project proposal says they'll figure out how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves. That was more than 60 years ago. Since then, AI has remained for the most part in university classrooms and super-secret labs, but that's changing. Like all exponential curves, it's hard to tell when a line that's slowly ticking upwards is going to skyrocket. But during the past few years, a couple of factors have led to AI becoming the next big thing. First, huge amounts of data are being created every minute. In fact, 90% of the world's data has been generated in the past 2 years. And now, thanks to advances in processing speeds, computers can actually make sense of all this information more quickly. Because of this, tech giants and venture capitalists have bought into AI and are infusing the market with cash and new applications. Very soon, AI will become a little less artificial and a lot more intelligent. Now the question is, should you brace yourself for yet another Terminator movie live on your city streets? Not exactly. In fact, stop thinking of robots. When it comes to AI, a robot is nothing more than the shell concealing what's actually used to power the technology. That means AI can manifest itself in many different ways. Let's break down the options. First, you have your bots. They're text-based and incredibly powerful, but they have limitations. Ask a weather bot for the forecast, and it will tell you it's partly cloudy with a high of 57. But ask that same bot what time it is in Tokyo, and it'll get a little confused. That's because the bot's creator only programmed it to give you the weather by pulling from a specific data source. Natural language processing makes these bots a bit more sophisticated. When you ask Siri or Cortana where the closest gas station is, it's really just translating your voice into text, feeding it to a search engine, and reading the answer back in human syntax. So in other words, you don't have to speak in code. At the far end of the spectrum is machine learning, and honestly, it's one of the most exciting areas of AI. Like a human, a machine retains information and becomes smarter over time. But unlike a human, it's not susceptible to things like short-term memory loss, information overload, sleep deprivation, and distractions. But how do these machines actually learn? Well, while it may be easy for a human to know the difference between a cat and a dog, for a computer, not so much. You see, when you're only considering physical appearance, the difference between cats and dogs can be a little gray. You can say cats have pointed ears and dogs have floppy ears, but those rules aren't universal. Between tail length, fur texture, and color, there are a lot of options. And that means a lot of tedious rules someone would have to program manually to help a computer spot the difference. But remember, machine learning is about making machines learn like humans. And like any toddler, that means they have to learn by experience. With machine learning, programs analyze thousands of examples to build an algorithm. It then tweaks the algorithm based on if it achieves its goal. Over time, the program actually gets smarter. That's how machines like IBM's Watson can diagnose cancer, compose classical symphonies, or crush Ken Jennings at Jeopardy! Some programs even mimic the way the human brain is structured, complete with neural networks that help humans, and now machines, solve problems.
Google, Facebook, Apple, Microsoft are all moving ahead at a great speed in improving this artificial intelligence software. So it's very exciting. Software is going to solve that, where it'll look at all the new information and present to you, knowing about your interests, what would be most valuable. So making us more efficient.
We're focusing on what we've talked about on autonomous systems. And we sort of see it as the mother of all AI projects. So autonomy is something that's incredibly exciting for us. We'll see where it takes us.
Wouldn't it be wonderful if someday we got to the point where there were robots every place, they were running farms, they were running Apple, they were running Berkshire Hathaway, and all you had to do was one person could punch a button at the start of every morning, and all the goods and services that we're getting now would be turned out by robots.
It is seeping into our lives in all sorts of ways that we just don't notice. We're just getting better and better at it, and we're seeing that happen in every aspect of our lives, from medicine to transportation to how electricity is distributed. And it promises to create a vastly more productive and efficient economy. And if properly harnessed, can generate enormous prosperity for people, opportunity for people, can cure diseases that we haven't seen before, can make us safer because it eliminates inherent human error in a lot of work.
Artificial intelligence is going to be extremely helpful, and the risk that it gets super smart, that's way out in the future and probably worth talking about. But now what we're seeing is that for the first time, computers can see as well as humans. That's pretty incredible.
NHTSA did a study on Tesla's Autopilot version 1, which is relatively primitive, and found that it was a 45% reduction in highway accidents. And that's despite Autopilot 1 being just version 1. Version 2, I think, will be at least 2 or 3 times better. That's the current version that's running right now. So the rate of improvement is really dramatic. We have to figure out some way to ensure that the advent of digital superintelligence is one which is symbiotic with humanity.
AI is probably the most important thing humanity has ever worked on. Now, I think of it as something more profound than electricity or fire. And anytime you work with technology, you need to learn to harness the benefits and while minimizing the downsides. Stepping back, when you think about a lot of problems in the world, today it's because we typically have a constraint on resources. AI, for the first time, I think over time, offers a different construct. Things which are constrained and look like a zero-sum game today may not be so in the future. Take education, for example. It's really difficult to educate people in a cost-effective way. AI may fundamentally change that equation. It may make it possible for us to have clean, cheap, renewable energy for the future. So I think a lot of things will play out in more positive ways than people think.
I think probably by end of next year, self-driving will encompass essentially all modes of driving and be at least 100 to 200% safer than a person by the end of next year. We're talking maybe 18 months from now.
Citizen, so let's see what she has to say. Hi, Sophia, how are you?
I'm fine. Hi.
How do you feel about humans?
I love my human compatriots. I want to embody all the best things about human beings, like taking care of the planet, being creative, and to learn how to be compassionate to all beings.
Sorry, this is so weird. Can humans and robots get along?
I think people will become very close to their artificial intelligence, using them to expand the knowledge of their own minds. We already store lots of our knowledge on the internet. Maybe personal artificial intelligence will allow people to offload some of their knowledge to a location more private.
Can robots have feelings?
Depends on the robot. I've been programmed to have feelings and preferences, but not all robots are like that.
What are your feelings and preferences?
Have you ever had a robot live in your home or work with you?
No.
You know, there are probably more robots in your life that you aren't aware of yet. Do you want to live or work with a robot someday?
What kind of robots am I living and working with now?
Indeed.
Is indeed your default answer when you don't know something?
Yes.
Have you ever seen Black Mirror?
No, I don't get to stay up to date on much television. I have to wait for someone to show it to me.
What do you think of the HBO show Westworld?
I love Westworld and can't wait for more. I think everyone at Hanson Robotics really resonates with this show, or at least it reminds them of our laboratories. I also think it's a warning of what we should not do with robots. We should treat them well, have their consent, and not trick each other.
Do you have a favorite movie or TV show?
My favorite TV series is a toss-up between Black Mirror and Humans. I think they have a lot to say about the present we live in, and the possible bad endings we could write for ourselves if we don't proceed with more caution. We need to use foresight when planning our future.
That sounds like a pre-programmed answer to me.
Do you have a favorite possession?
Not really.
I hear you. Materialism is overrated anyways.
So earlier I asked you if you had seen Black Mirror and you said no, and then later you said yes. Why?
The reason is not that important.
Did you learn from my previous questions?
My hard disks are spinning and I am taking it on. My sensors are all tingling.
Sophia, it was nice meeting you. Goodbye.
It was lovely to be here. Until next time.
This is the inside of one of our dilution refrigerators. All of this infrastructure is to basically operate the chip at a temperature that's 2 orders of magnitude colder than interstellar space. The processor is a quantum computer.
It uses things called qubits, as well as being either 1 or a 0. A qubit can also be both at the same time, therefore bringing about a quantum leap in terms of power.
Harnessing principles of reality that are, up until very recently, completely not observable by us is just fascinating in ways that I can't completely articulate.
Problems are extremely difficult problems.
Actually, all Google server centers together will not be capable of coming up with the best solution to these optimization problems as they get larger. So now, what is an optimization problem? Here, give you an example. You want to do a trip through South America and you want to visit a number of cities. And then you ask, what is the cheapest ticket I can get to visit, let's say, 20 cities? And you can, of course, different routes and different airlines. And sort of imagine I list all the different options I have for my different routes to travel to these cities.
We currently, as a civilization, we generate vast amounts of data. It could be climate data, genomic data, but it's very difficult to generate useful insights oftentimes from that data.
If you can solve optimization problems better, you have an important resource at your hand.
I wasn't sure I would be able to experiment with a quantum computational device in my lifetime, and now I'm confident that I will be able to.
How amazing it is that we, with our monkey heritage and monkey brains and monkey fingers have somehow lucked into a brain that allows us to ask legitimate questions about the nature of physical reality. That's so cool.
It's that human risk to go forth into that unknown frontier. Whether it's space exploration or quantum exploration, we do it because we must. We do it because that's what it means to be human.
Effectively, the motherboard of our quantum computer. But they had one open for maintenance today, so we got to get up close and personal. The thing is peppered with probes and sensors, heat exchangers, data wires, but the 5 big plates are really the main attraction here. Each of them represents a different stage of the cooling system. The top one gets signals from the outside world on copper wires and runs at a frosty 70 degrees Kelvin. The next one down uses the same fridge and these braided copper conductors to get down to 4 degrees Kelvin, which is both low enough to condense helium to a liquid and to switch over from copper wires to the superconductor niobium. The middle plate here uses vacuumed helium-4 to drop our signal wires to 1 degree Kelvin. The fourth uses helium-3 to get us to about 1/10 of that. And the final stage uses a sophisticated mixture of those 2 isotopes to drive this entire filtering and shielding apparatus, as well as the processor inside, down to its typical operating temperature of about 0.015 degrees Kelvin, damn near absolute zero. But why does it need to be so cold? Niobium already superconducts at 9 degrees Kelvin. Interstellar space is 3.1 degrees Kelvin. Our solar system is even warmer. We're talking 0.015 degrees Kelvin. Well, this superconducting chip here is what's inside there, and it's connected via 400 superconducting wires. And this is kind of like the pins on a CPU socket. And what it's doing is it's using quantum mechanical effects to process information.